In this video, I'm going to cover a problem related with the block on an inclined frictionless surface. So as per the diagram given, for the block released at rest on a frictionless surface, find the weight of the block perpendicular to the inclined surface, parallel to the inclined surface, find the value of the normal force on the block, also find the net force perpendicular and parallel to the inclined surface, eventually find the acceleration of the block, and with what velocity will the block hit the ground, also the time it takes to hit the ground, and repeat the calculation if there is an initial velocity of the block given. I would highly encourage you to go through my earlier video highlighted below that explains the concepts applicable to this problem. Let's start. So let's focus on the first part, that is the weight of the object. So the weight of the object is given by mg, and with m equal to 1 and g equal to 10, so we will get this as 10 Newton. And this has been shown over here. So mg equals to 10 Newton acting at the center of mass of the block, acting vertically down. And in that, we have to show the two components of the weight. So first component is perpendicular or normal to the surface. So that component, if I can, you can always refer to this video that I have prepared that explains the conceptual understanding of the topic. Nevertheless, I'm going to reuse all the concepts from there which are relevant for this numerical. So in the triangle, we have, if I can make this as 90 degree, so which means this will be 90 minus theta, because the angle of inclination is theta. Yeah, and which means due to corresponding angles, this will also be 90 minus theta, and therefore this means this will be theta. So the perpendicular component to the normal surface will be mg cos theta. Okay, so if you take the component which is aligned with the angle theta, for which this side is the adjacent side, this will be mg cos theta. And why we call normal component? Because it is perpendicular to the inclined surface. Yeah, and so perpendicular component will be equal to mg cos theta. That is, m is given as 1, g is given as 10, so I can write this as 10 cos theta. But what's cos theta? Is that given to us in the question? So if you see this triangle, so maybe I can call it as A, B, and C. So in the triangle ABC, if you apply the Pythagoras theorem, so you will get the sides as 3, 4, and 5. Yeah, side AC will be equal to 5 meter, and therefore cos theta will be equal to, therefore it will become 10 cos theta, and cos theta in this case will be 4 over 5. So this will be 8 newtons. So in the diagram, this component will be equal to 8 newtons. And coming to the part B, which is the component of the weight force, which is acting parallel to the inclined surface, will be this one, mg sine theta. Yeah, and therefore that will be equal to mg sine theta. So m times g is 10, and sine theta in the triangle ABC, as you see, should be 3 over 5. So which means this should be 6 Newton. So I can write this as equal to 6 Newton. So we have completed both the parts for the first part of the question. Now the second part of the question is to find the normal force. So that is Fn. So Fn is the normal force exerted by the earth or ground. If I just call this as earth or ground, there will be a normal force exerted by earth or ground on the block. And this force will also be acting at the center of mass of the block. So that will be equal in magnitude to the component mg cos theta. Yeah. Why? Because the block is not having any motion in the vertical direction. Therefore, the force acting in the upward direction should be equal to the force acting in the downward direction, which means no net force. So which is possible only when Fn is equal to mg cos theta. And we know that that is already calculated as 8 Newton. So this will be equal to 8 Newton. So we have finished part 2. So coming to the part 3, the net force acting on the block. So that will be, we have to find the net force acting on the block along the perpendicular. Okay, so we have to find this. So our y and x-axis are in this direction. So perpendicular or normal to the surface, I will call it as y-axis, and positive x-axis going down. So if we apply Newton's second law, so sum total or vector sum of all the forces acting along y direction should be equal to 0. Why it should be 0? Because the block is not moving in the y direction. Therefore, there is no acceleration, and therefore the net force should be 0. Okay, so what are the forces? So as I have already indicated, let me represent the vector form of the equation. So that's the normal force plus the component of the weight, which is, so maybe I can write weight along y direction should be equal to 0. Okay, and which is possible only when the magnitude Fn should be equal to weight, magnitude of the weight along the y direction. So since there is no motion of the block along the y direction, we say that the net force on the block is 0. And how about the net force along the x direction? That means along the inclined surface. So apply Newton's second law again. This time it will be sigma fx. This should be equal to, the general expression is mass times acceleration. But before I go further, we see clearly that there is only one force acting along the x direction, and that is given by mg sine theta. Since there is only one force, therefore the block will be moving in the direction of the inclined plane along the x-axis. And it has been given in the question that there is no friction on the surface. So which means Ff, force of friction, will be equal to 0. So if we apply Newton's second law, this will translate to weight of the object acting along x direction should be equal to mass times acceleration. In terms of simple magnitudes, I can simply write this as mg sine theta should be equal to summarize our answer, what is the net force along the x direction? So net force along the x direction is equal to mg sine theta. And we have already calculated that before, that is 6 newtons. Coming to part 4, what is the acceleration? So I already did a part of this under this condition. So if I utilize this, let me rewrite mg sine theta will be equal to ma. Cancel m on both the sides. So acceleration will be equal to g sine theta. So that will be 10 times sine theta. Sine theta is 3/5. So this should be 6 meter per second square. So just one side observation. Since the value of sine theta will always be less than 1 in the first quadrant, therefore value of acceleration will always be less than g. So g is given as 10. So keep a track of it that all your values are agreeing with the expected value ranges. So 6 is less than 10. Let's now focus on part 5. With what velocity will the block hit the ground? So as we have seen, the block will be sliding along the inclined surface, and at some point it will hit the ground. So when we say hit the ground, so I've tried to explain it like this. So the side PQ of the block, which I've shown here, the object will keep on sliding, and exactly at point C of the triangle, the side PQ will hit the ground. So that's what we determine as that the object has hit the ground. Okay. So P dash Q dash will be the position of the side when it is hitting the ground. Okay, so in terms of the linear distance that the block will travel will be equal to, so the distance that the block will travel will be equal to S, and that is given by QC. Okay, but how do we find out QC? So QC can be easily written as AC minus AQ. So AC, we know it is 5 meter, minus AQ, which is given as 0.5 meters. So this will be, so S will be equal to 4.5 meters. Now we know that the object was dropped at rest, and we have to find the final velocity with which it will hit the ground. And from the previous part, we know that acceleration is 6 meter per second square. Now, these are the three equations of the linear motion that we are already well aware of. Let's see which one is most appropriate to be used. Clearly, the first and the third cannot be used because it has time, which is not given to us. So we have to focus on the other equation. So V is something we have to find, U is given, A we have calculated, and S also we have calculated. So let's put the values and see. So V square minus 0 will be equal to 2 times acceleration, which is 6 times distance 4.5. And therefore, V will be equal to square root of 54, which comes to around 7.3 meter per second. All right, now coming to part 6. So continuing with this flow, after how much time will this block hit the ground? So this time we have to find time, and for which we can use any of the remaining two equations, but the simpler one to be used is V equals to U plus 80. So let's use that. So V will be equal to U plus 80, and therefore T will be equal to V minus U over A. And V is 7.3 minus 0 over A, which is 6, comes to roughly 1.2 second. So let's continue with part 7. It says that had the initial velocity been 1 meter per second, how the things would have changed. What would be the final velocity? So velocity is what, and what is given is, and acceleration is given as 6 meter per second square. So we apply the same set of equations as I have done before, and see the new value. So V square minus U square will be 1, should be equal to 2 times A is 6, and S is 4.5. So that will be equal to 54. So V square will be equal to 55, which means V is square root of 55, and that comes to roughly 7.4 meter per second. Also, you can compare the two values. So the final velocity in the earlier case, when it was starting from rest, at that time it was 7.3 meter per second. Now that there is a initial velocity of 1 meter per second, therefore the final velocity in this case definitely is expected to be higher than the previous case. So 7.4 is slightly higher than 7.3. So our calculations are pointing in the right direction. Now there is also a other part. What will be the time for the object now to hit the ground? So we can use the same equation, V equals to U plus 80, so which means 7.4 divided by A, which is 6, should be equal to T. So this comes to 7.4 minus 1 divided by 6 should be equal to T, which comes to 1.06 seconds. So as expected in the second case, the time 1.06 second is definitely expected to be smaller value as compared to the earlier case of 1.2 seconds. So this is one way in which you can keep verifying your answers to ensure that the values are aligned properly. Thanks for watching the video. Please like, subscribe, and share, and kindly drop your comments. They help us. Thank you.